Can you see my web page?
Yes, sir.
Yes.
All right. There are Zoom meetings that you need to be watching as you go along. Main thing is you have to watch Zoom meeting for chapter 1 and chapter 2. Then the test going to be on right here, second item from the bottom, test 1, chapters 1 and 2. It will be given on September 13th.
Okay.
From 9 to 10 p.m. 9 a.m. to 10 p.m. I will send you the passport. Then you need to do the quiz 1 and quiz 2. Okay? Ideally before the test, taking the test. But the deadline is set for September 30th or something, maybe after the test 1. But you need to be doing it before that. All right? Do you have any questions about the course webpage?
No, sir.
Course webpage.
No, sir.
Okay.
No, sir.
All right. I'm going to share my slide for chapter 2. Can you see my chapter 2 slide page about the atom?
Yes, sir.
Okay. Let me.
Yes, sir.
It's going to be on September 13th. It covers chapters 1 and 2. So we're going to cover chapter 2 today.
Okay.
I have gone over the chapter 1 material. I have 2 Zoom meetings with the complete details about what I talk about during these chapters, chapter 1. So please go, and if you have missed chapter 1, go and watch the Zoom meeting video for chapter 1. So we're going to talk about the atom today. Let me get it set it up.
Yeah.
We're going to go over the classification of matter.
Yes.
Can you see my chapter 2 first slide?
Yes, sir.
Okay, we're going to talk about classifying matter. We classified matter as pure substances and mixtures. Pure substances and mixtures. Pure substances are elements and compounds. Elements and compounds. Mixtures are combination of different combination of elements and compounds. So we're going to look into that briefly. Now, important idea about this chapter is atomic theory. We came up with the idea about atom, and for atom is coming from observations. Then we came up with Dalton's atomic theory. We're going to look into that. The atoms are composed of neutrons, protons, and electrons. Most of you know about it. Nucleus is where you have neutrons and protons. Electrons travel around the nucleus. That's the basic idea about the atom. Composition of the atom is neutrons, protons, neutrons. Okay. Now atoms are made out of protons. Okay. Now there's a table called periodic table where all the elements, known elements are arranged in a table according to chemical reactivity. We're going to look into that after we've gone over the atom. Now, important thing for chemistry is electrons, how the electrons are arranged around the atom. around the nucleus of atom, because outside electrons are the chemical reactivity, how they share or gain or share or lose electrons. Chemical reactivity is based on that. So we have to know the electron arrangement of around the nucleus of atom. So there's a one way to get the electronic configuration, that is using periodic table. So we're going to tie electronic arrangement to periodic table after we go over this. We're also going to look into periodic properties. Do you have a question? Can you turn off your mic if you're not asking a question? All right. So we're going to go through details about classification of matter, mixtures, elements, and compounds, atomic theory, basic parts of neutrons, protons, electrons, basic features of periodic table. Then we're going to classify elements according to metal, non-metal, metalloids. And also we're going to talk about atoms have different masses called isotopes. They are called isotopes. Then try to understand the electronic structure of atom, arrangement of atom. Basically, chapter 2 titles in detail. I'm going to come back to this and look into that details again later. Now I am going to review a little bit of classification of matter. Matter is pure substances and mixtures. Pure substances, mixtures could be separated into pure substances by physical means, distillation, filtration, crystallization, like that, physical method. Pure substances are elements and compounds. Elements have only one kind of atom. Compounds have different kind of atom in fixed ratios. On the other hand, mixtures are a combination of pure substances, elements and compounds. They could be homogeneous, heterogeneous, depending on the distribution of the uniform distribution is homogeneous. Non-uniform distribution of the matter is heterogeneous. Element is a pure substance. For example, carbon, hydrogen, iron. They consist of identical atoms. We need to talk about isotopes. Except for types of isotopes, they have same number of protons, same number of electrons. The neutron number could be different. There are 118 known elements. 98 of them occur in nature. Others have artificially made by physicists in particle accelerators. Elements have symbols, consist of one or two letters. Carbon is one letter, C. Iron is Fe. Because iron in Latin is ferrum, Fe. That's why we give the name Fe to iron. So two letters. Names are derived from variety of sources. English name of the element. Sometimes people are named. People's names are used. Important scientists, geographic location, planets, mythological sources, etc. The names are derived from these criteria. Compound is a substance that made out of two or more elements in a fixed ratio. Formula of a compound tells the ratio of the element, like water, H2O, 2 hydrogen, 1 oxygen. The ratio tells the fixed composition by mass. Sodium chloride contains 1 chlorine atom and 1 sodium in the form of sodium ions and chloride ion. That's an ionic compound. Water is in the ratio of 2 hydrogen to 1 oxygen. So that's how you identify more than one element making up a compound is called pure compound. Mixtures are a combination of 2 or more pure substances. Mixtures could be element and a compound, or 2 compounds, 2 elements, different combination. It could contain 1 or 2 pure substance or complex mixture of pure substance. They have no mass ratio, fixed mass ratio. It depends on the amount of pure substances you mix up. Each substance has a different set of physical properties. Therefore, mixture will not have fixed physical properties. Elements and compounds have fixed physical properties. Mixtures could be homogeneous. We talked about that. Which is not a pure example of a pure substance. Look at 4 choices. Sugar is what kind of thing is sugar? It's sucrose. It has a fixed C12H22 or oxygen also 12. Sugar has fixed carbon-hydrogen-oxygen ratio. That's a compound. Okay, what do you think the not a pure substances among them?
Air.
Air is a mixture of elements. That's correct. Aluminum water is pure compound. Carbon dioxide is dry as pure compound. B. Element is a pure substance which can be broken down into simpler substances by physical means. That's not true. Cannot be broken down into physical means. That seems to be correct. Can be broken down into by chemical means. No, cannot be broken down into the substance by chemical means. Cannot be simpler by physical means. Out of these, elements cannot be broken down into substances by chemical means. Elements cannot, B is also, I am curious, broken down in simpler physical means. Normally, physical means is you cannot break down elements by physical means. Only way to break down substances by chemical means. Therefore, B doesn't apply. D is the correct answer. Let's look into these 2 different elements that combine to form another substance to form compounds. When a substance A reacts with substance B, a new substance C is formed based on this information. You don't know A and B. It could be elements or pure compounds or compounds. A could be a compound, B could be a compound, C must be a compound. What do you think? For sure, a new substance is formed. Therefore, if 2 different substances combined, must be a compound.
They could all
No.
be correct.
All choices are correct. Both A could be element, could be. A could be a compound. B could be a compound. That's possible. C must be a compound. That's possible. Answer is E. Do you have any questions about that?
No, sir.
E is the correct answer. Go back and think about it. Okay? Elements and compounds are both classified as pure substances. True or false?
True.
You are correct. Compounds. When a strong magnet is brought near a sample that contains both iron and sulfur, the iron and sulfur are not separate from one another. Which type of the matter is this sample? Iron combined with sulfur. Iron sulfide don't have a magnetic property. Iron alone has, sulfur alone don't have magnetic property. Mixture of iron and sulfur still could be separated because iron would be attracted to magnet. What do you think? It is a compound.
It is. Yes.
Yes. Is it a homogeneous mixture?
No. It's A.
It's definitely a compound. Okay? We don't know how they didn't tell you about the distribution of sample. It is definitely a compound. Sodium is highly reactive metal and chlorine is a toxic gas. When they are mixed, they form sodium chloride, which is essential for life. Which of the following statement is true? When sodium and chlorine are brought into contact with each other, form a heterogeneous mixture. It's a compound is formed. It's not heterogeneous. They form a homogeneous mixture. It could be. They form a compound. That is for sure.
Yes.
They may form heterogeneous. What do you think answer is?
C. For sure.
Okay.
C.
C is the correct answer. Nitrogen gas will be properly be classified as a compound. True or false? Only one kind of atom, nitrogen. Is it true or false?
No, it's false.
A compound cannot be broken down into simpler substances.
False.
Compound could be chemical means it could be broken down. Now let us look at mixtures. Which of the following statement describe a mixture? Components of the elements of a mixture can be present in any mass ratio. No. That's correct. Sorry about no. Any mass ratio. Mixtures don't have fixed mass ratio. The chemical techniques are required to separate the mixture separate the components of a mixture. Mixtures are separated by physical means. Therefore, it's false. First one seem to be correct. The component element of mixture can be present in any mass ratio, and chemicals are required to. That's not true. chemical techniques are not the one that separate mixtures, physical one. The component elements of a mixture cannot be present in any ratio, and chemicals are not required to separate the component of a mixture. Between A and D, but for sure that's a definite answer is A.
Okay.
You are not given a choice between A and B, A and D. In MEM, the chemical are not required to separate the chemical component. You have to say physical techniques are used. Chemical are not used. Therefore, most correct answer is A. When a sample of a particular solid is examined under microscope, clearly black and yellow regions are observed. That which type of a matter is there? Heterogeneous, right? Black and yellow region. That's heterogeneous. D.
Okay.
Okay, we done with classification of matter. We want to look at the atomic theory, how it's developed. Dalton is the one who came up with atomic theory. John Dalton, a British scientist. He came up with the theory based on observation. All matter is composed of very tiny particles, which are called atoms. All atoms of the same element have same chemical properties. Atoms of different elements have different chemical properties. Periodic table are list of elements, table of elements. They have different chemical properties. All elements have different chemical properties. Each element has similar chemical properties, atoms of each element. Now, formation of compounds are combination of two or more atoms of different kinds. That's the compound we talk about, elements and compound. Molecules are tightly held combination of two or more atoms that act as a single unit. Molecule is a unit that is bonded by bonds, chemical bonds, like water. Now, what are the evidence for Dalton's atomic theory? There are three observations and three patterns in observation. Patterns in observation are called laws. Law of conservation of mass. When a chemical reaction takes place, mass is conserved. Mass can be neither created nor destroyed. If matter is made out of indestructible atoms, in a chemical reaction, they don't get destroyed, only form different bonds, attachment, but the atoms remain intact. That's the idea about law of conservation of mass. Atoms before and atoms after, same mass, but the combinations are different. For example, carbon monoxide and lead oxide react to make carbon dioxide and lead. Now the lead is giving one oxygen to right here to that. They are recombination. Therefore, it's a chemical reaction. Mass are conserved. Now, we also touch upon this idea, law of constant proportion. When two chemical elements react with each other, they form a compound. Compound contains fixed or constant proportion by mass. For example, water has fixed ratio of masses in water molecule. Law of constant proportion is given by Joseph Proust, a French chemist. If you take 36 grams of water, you can obtain 4 hydrogen grams or 32 oxygen. Mass is conserved, but ratio of hydrogen to oxygen is 1:8. This is a fixed mass ratio. Always mass ratio in water, anywhere you can find water, is always 1 hydrogen to 8 oxygen in grams. That's called the law of constant proportion. For example, that explains these 4 grams of water, hydrogen, plus 32 grams of oxygen gives 36 grams of water. It could be broken down into 4 grams and 32. That's the law of constant proportion or fixed proportion. Now, Dalton also knew this idea that there are 3 laws: conservation of mass, law of constant proportion, law of multiple proportion. When 2 elements combine to make a whole number multiple ratios, for example, carbon monoxide and carbon dioxide. This carbon join is 1 oxygen and a 2 oxygen. This explains that idea. For example, Dalton knew when 2 elements of carbon, oxygen combine in different proportions. This is 1:1. This is 1:2. The ratio between the second elements is 1 multiple proportion. 1 and between 1 and 2 is multiple of 2. So this idea, when 2 elements react to form 2 different compounds, both have same number of carbon atoms here, 1 here. First compound combined with 1 oxygen, second compound combined with 2 oxygen. The multiple ratio is 1:2. So when you have a reaction between 2 different elements forming 2 different compounds, you have the law of multiple proportion. The fact that, let's answer some questions about Dalton atomic theory and chemical laws. The fact that chemical compounds contain the same element in exactly the same proportion by mass ratio, by mass, regardless of the size of the sample, known as exactly the same proportion. What is that law is called? Law of constant proportion, and is the answer. The definite proportion and constant is same. Let's look at another side. Fact that 2 different elements, carbon and oxygen here, combine to form more than 1 compound, carbon monoxide, carbon. The weight ratio of the 1 element that combine in the other are small whole number ratios, 1:2. What is this statement describe? What kind of a chemical law? When two elements combine, we said it multiple proportion. When two elements combine in a fixed ratio, it's called law of constant proportions or definite proportion. Therefore, answer to this 49 should be what?
A.
B.
There's no law of determining proportion. Law of multiple proportion, law of definite proportion, law of... There are only three laws. I never heard about this. Only thing is this one. Definite means constant. For this fits A. Let's look at another question. The chemical equation shows calcium carbonate is heated. Which of the statement describe the mass of the product if you heated up 100 grams of calcium carbonate? The difference in the product masses is equal to the mass of carbonate. Sum of the product masses is less than. Let's look at the difference between product masses is equal to the mass of the. Let's look at sum of the product masses are less than. That's not true. That's not true. That's true. That's law of conservation of mass. Mass of each product is equal to the mass of calcium carbonate. Sum of the products' masses are equal to the mass of. That's mass of each product. That's not true. This one is true. Sum of the product. So what should be the answer? Difference in product mass doesn't make sense. The A is not correct. Only we remain is D. Mass composition data for the two compounds containing sulfur and oxygen is shown in below. This experiment data follow law of multiple proportion. If you have sulfur, this is multiple proportion. Is 1 to 2. 1 divided by 1 to 3. The first element is sulfur. Therefore, this should be sulfur dioxide, sulfur trioxide. Which one should be the correct answer? Two sulfur oxygen compounds should be
B.
B.
Mhm.
Okay, got it. Atomic view of matter. Matter could be made out of molecules, which are monoatomic. Molecule is a free particle, simple particles of atoms. Monoatomic means only one atom. Two atom means two diatomic. Polyatomic means more than two. For example, noble gases have only one atom, helium. They don't make diatomic. Oxygen exists in O2. Ammonia is a polyatomic. It has NH3, 4 atoms. There are 7 elements that occur as diatomic molecules. Hydrogen, chlorine, fluorine, bromine, iodine, oxygen. Did I say hydrogen? You can look at the periodic table. There are diatomic molecules. Okay, that's the 10. 7. These are the 7. Polyatomic molecules. Ozone is a polyatomic. ozone has O3. Phosphorus is P4. Elemental sulfur is SA. There are clusters, gigantic clusters, like diamond. Diamond is a big molecule connected to carbon atoms connected to each other in a 4-bond formation. Carbon make 4 bonds. That's a very strong structure. If you look at this picture, when you look at the Coke glass, chemical view of a matter, atomic view of matter, that's the sugar molecules. This is carbon dioxide. This is water. There are plenty of water. So that's the atomic view of matter. In a lead pencil tip is made out of graphite. When you write on the paper, the graphite is laid on paper as you move the pencil. Graphite sheets slide on each other, therefore easy to write. That's the chemical view of atomic view of matter. If you look at your hand here, we are made out of proteins. Proteins are amino acids. These are amino acids. There are alpha helixes of amino acid chains. That's how we look into atomic view of matter. Now we're going to look into atomic view of in terms of composition. We do the questions. Which Greek philosopher thought that matter was infinitely divisible? Zeno is the one that who talk about paradoxes. Infinitely divisible. Democritus is the idea atom is indivisible. Ultimately, you read Zeno is the one credited for infinitely divisible matter. Word atom is derived from Democratic Greek. Democritus is the one who thought indivisible ultimate particle is atomos. Which of the following best compares Democritus view of matter and our current view? The Democritus view is based on belief only. There's no experiment. The both view, current view and current view is only based on experimental evidence. Therefore, this is wrong. The ancient view is based on thoughts only, but current view is based on experiment. That's not true. Democritus didn't do experiment. Philosophers ideas are based on belief. So this is wrong. I didn't mark it right. Both views are based on belief only, but the current view is not based on. Therefore, C is the only correct answer. We're going to look at the atomic view, names of atom and symbols of elements. The symbols of element in the periodic tables are derived from 3 languages. Which of the following is not one of these languages? English, of course. English dominates. Latin dominated.
French.
I don't know why French didn't get the name elements. Okay, that's the B is the correct one. Which of the following element is named after continent. Astatine is arsenic, Latin name. That's not a continent.
Okay.
Orus is gold, name for Latin. Europa, EU is Europa, Europe. Therefore, C is the correct answer. Which of the following element is named after country? Francium, germanium, polonium.
D.
All of these. Which of the following elements is named after a city? Boron, beryllium, bismuth, berkelium. Berkeley is a berkelium. Berkeley is a city in California. Which of the following elements is named after a person? Europium, francium, osmium. Sg is what? Seeberg. Seeberg is an American chemist who came up with the long form of the periodic table. Seeberg is the Sg.
Okay.
Which of the following element is named after a planet?
U.
European.
Mm-hmm.
Uranus. Uranus is U. Okay. Which of the following is not a symbol of an element? Carbon, calcium, carbon monoxide, cobalt. This is a compound. All other three are, except C is element. Therefore, answer is C.
Okay.
Okay, if you look at the modern view of water molecule, you can write down a formula, H2O. You can write down a structural formula, shows bonding. Ball and stick model, which are balls are represented by atoms. Electron cloud distribution is called space filling model in terms of electron cloud. That's called a space model. There are three models we use for molecules: formula, structural formula, ball and stick model, and space filling model. You will see different models are used in the description.
Mm-hmm.
Now, we're going to look into the composition of atoms. Atoms are we thought to be indivisible according to Dalton and Democritus. But now we find they could be subdivided, broken down into protons, electrons, and neutrons. There are three subatomic particles. You have to know their charges. Proton is +1, electron is negative, neutron is no charge. Mass, proton mass is, this is grams, 1.67. Neutron is little heavier than, if you look at this, little heavier than proton. Electron has a very small mass.
Mm-hmm.
So rounded off the mass, protons and neutrons have the same mass. Compared to protons and neutrons, electron has a smallest mass. Protons are found in the nucleus. Nucleus is the central part of the atom. Electrons travel around the atom. So there are three subatomic particles. You had to remember these ideas. Normally, we use atomic mass unit. One atomic mass unit is this. One atomic mass unit is 1 grams per mole. In the periodic table, we use atomic mass unit to grams per mole. That's the same thing. So one atomic mass unit is equal to 1 grams per mole. Which of the following statement correctly described an electron? Electron have negative charge. Negative. On the scale of Saturn, it is the massive and that's not true. On the scale of Saturn, it has a massive negative charge. That's not true. On the particle, it is light and has a positive charge. That's not true. It has light and has, D is the correct answer. Do you see that? What is the approximate mass of electron? Did you see in that table we came up with AMU? Which of the statement is true of nucleus of atom? Nucleus occupies a tiny fraction of the total volume of the atom. That's true. And most of the mass of the atom is concentrated in the nucleus. That's correct. Nucleus is a very small compared to volume of the nucleus occupies large fraction of total volume, but that's not true. The nucleus occupies a large fraction of total volume, most of the mass is, that's not true because the end statement, this is correct, this is wrong. Therefore, so far A is the correct answer. Now let's look at atomic symbol and atomic number. Mass and atomic number. Mass number is called A. Atomic number is called C. Mass number A is the sum of the protons and neutrons. Number of protons plus number of neutrons. Electrons are same as atomic number in a neutral atom. Atomic number is the number of protons in the nucleus. That's fixed for atomic number is same for atoms of one element, one type of element. Now I'm going to talk about atoms have different number of neutrons, isotopes. Therefore, we have to write down the atomic symbol with the atomic number here and the mass number there. So that's how we write detailed atomic symbol. If you have element, Mass number is here. Atomic number is here. I'm sorry, this mass number is A. Carbon 12. 12 is the atomic mass number. Carbon is 6 protons. So atomic number is subscript, superscript is atomic mass number. Now I just described a little bit about isotopes. Atoms have same number of protons, but could they have different number of neutrons? They have the similar chemical properties, but they can have different masses. They are called isotopes. Carbon 12 has 6 protons, 6 neutrons. Why? Carbon 12 is there's a mass number here, atomic number. Mass number A minus atomic number gives number of neutrons. 6 minus 12 is 6 neutrons. So you have to be able to get the number of it from the atomic symbol. Normally we write down this or the same as this carbon atomic symbol. Carbon 13 has 6 protons, 7 neutrons. Carbon 13 is a second isotope of carbon. Carbon 14 has 8 neutrons, same number of protons. Most elements found on Earth are a mixture of isotopes. Therefore, you have to understand when you say an element, it's a mixture of isotopes. For example, chlorine. 75 of chlorine atoms is chlorine 35. 24% is chlorine 37. Chlorine 37 has 2 more neutrons than chlorine 35. So you have to understand isotopes are atoms of the same element with different number of neutrons in the nucleus. What is the answer to A? Gives the number of D is the correct answer. Sum of the protons and neutrons in the nucleus. Which of the following define the mass of an atom? Number of protons in the atom? No. Number of neutrons in the atom? C is the correct answer. Quantity 8 gives the number of electrons. A plus C. A is number of protons plus neutrons. When you add another C, it becomes number of electrons. Number of subatomic particles. All subatomic particles include. A is neutrons and protons. C is electron, same as electron number. C is same as, therefore D is the correct answer. Which statement describing atom is false? Number of protons in an atom is refers to as the atomic number of an atom. That's true. The total number of protons, neutrons, and electrons is atom is refers to as mass number. That's wrong. That's not the only these two are mass number. Protons and nu are located in the, that's correct. Electrons are located in the, that's correct. That's the B is the false. Mass number, then you added these two, you get 87. 38.49. C is the correct answer. Mass number. When you add these two, you get 59. Now, atom picture, we know that there's a nucleus where neutrons and protons are found. And outside, electrons move around outside the nucleus. The size of the nucleus is very small. This is the volume of the size of the atom is large. Therefore, there are a lot of empty space for electron to travel. That's the typical view of an atom. Now let's consider atom of lead. Lead is the same as lead, 208. It has 82 protons, 82 electrons, same number in the neutral atom. It has one, that's how you get the number of neutrons. Mass number minus atomic number. Mass of the lead atom is very small. 1 pound of lead is very large number of lead atoms. Diameter of a lead is 10 to the negative 10 meters. Nucleus is where you find protons and neutrons. Diameter compared to this, very small. Nucleus has a higher density. This is the density of the nucleus, very high. Therefore, you can get the idea about relative size of nucleus and the atom and how small the mass of the atom is. Now we're going to look into how we get average atomic mass. Most elements have more than 2 isotopes, like we described about carbon 12, carbon 13, carbon 14. Chlorine also has 2 isotopes. To get the average atomic mass, which is reported in the periodic table for chlorine, we have to take the average. Chlorine 35, that. Chlorine 37 is. So how do you calculate this? You take the fractional abundances, the fractional abundances. How do you convert percent to fraction? Divided by 100. Multiplied by mass of the 35, mass of the 37. You add them up. That's the calculation of fraction. This is the isotopic mass of 34 and 30, 36, and 30, 35 and 37. So in the periodic table, reported value is 35.45, depending on the measurement. So that's how you calculate the average atomic mass from the isotopic masses and relative abundance of naturally occurring isotopes. What is the atomic weight of fluorine? List each isotope, 35 and 37, and the natural abundance, 35 and 37. Natural mass of the isotope is 34.97, 36.97 for fluorine 37. So you get the fractional abundances multiplying percentage abundance. Percent abundance is here. Multiplied by 100, you get fractional. Then you add them up, fractional abundances, multiplied by isotopic mass. Four significant digits. Therefore, you have to round up to. That's how you calculate average atomic mass. Atomic weight of isotopic masses and abundances. Atomic weight from isotopic masses and abundances. Do some calculation. Which of the following is true of the atomic weight of an element? It is the weight of the heaviest isotope. No. It's the average. It is the weight of the lightest isotope. No. The weight of the most abundant isotope. No. The weighted average, that's the correct answer. If you have these two, this divided by 100, this divided by 100, multiplied by 298, multiplied by 298, 300. I'm not going to do it. This is the correct answer. If you added up fractional abundances multiplied by isotopic mass and fractional abundances multiplied by, that's how you calculate the average atomic mass. Classification of elements based on metal and non-metals. in the periodic table, some elements have certain properties. They are shiny, they conduct electricity. Based on that properties, there are metals, they are ductile and malleable. There are alloys. When you mix up metals heated up together, brass and copper and zinc, it's the alloy of brass. So you can get different mixtures. Homogeneous mixtures of metals are called alloys. In chemical reaction, metals tend to lose electrons, tend to give up electrons. Non-metals, on the other hand, except for hydrogen, are found on the right side of the periodic table. We want to show in the periodic table. Except graphite, they don't conduct electricity. Now, metals and non-metals are found in the periodic table. On the left side, you find metals. On the right side, you find non-metals. This Russian chemist, Dmitry Mendeleev, come up with the periodic table for the first time. What he did was all the known elements at that time, they probably knew about the atomic weights like we calculated in the previous slide. All the known elements are arranged increasing atomic weight, beginning with hydrogen. He put that in a table. He observed when elements are arranged in this manner, certain set of properties recur periodically. The periodic table is named because it has horizontal rows. In a horizontal row, you start with highly reactive metals and end up with noble gases. Metals become non-metals, then end up with noble gases. That's recurring property for each row in the periodic table. That's why it's called periodic table. He then arranged elements with recurrent set of properties in the same column. Column is a vertical row, vertical column. For example, if he arranged lithium, sodium, and potassium in the same column because they have similar chemical properties. So he came up with the table, which is very useful in chemistry. This is the periodic table that is available today. This is not the Mendeleev table after so many revisions. This is the periodic table. When you look at periodic table, there are seven rows here. Row is a vertical, horizontal column. There are 18 7 periods, 18 columns. If you count, this is 18 vertical columns. That's one thing you notice. One other thing, some of the elements following lanthanum and actinium is put outside. This lanthanide should have been inserted after 57 atomic number, 56. But this comes after 57 is 72. 14 elements are taken out from 6th period, and this belongs to 6th period. This belongs to 7th period. I cannot erase. So these elements taken out of the main columns are to keep the similar chemical behavior for each column. Now, when you look at this, there are different colors. These are called main groups. Main groups. These are called transition elements. Transition. These are called lanthanide elements, actinide elements. So this is the main idea about the periodic table. There are rows of periods, 7 periods, 18 groups or columns, and there are main groups. One of the questions we normally ask is, what is a main group element? These tall columns, these are taller columns. Elements belong to this area are in orange. Those are main groups. Any one of these elements could be main group elements. For example, chlorine, sulfur are main group elements. If I ask for lanthanide element, gadolinium, what is a beryllium? Beryllium is a main group. What is a transition element? Rhodium, or any of them in this yellow area. Now, there's also metalloid elements. There's a ladder going down here, bordering metal elements on the left and non-metals on the right. Metals, non-metals. The elements bordering, that's boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. There are 7 of them. Okay, so they are called metalloids. They have properties in between metals and non-metals. Do you have any questions?
No, sir.
Good. Metalloids have properties in between metals and non-metals. For example, they are shiny like metals, but they don't conduct electricity like metals do. But they are shiny. 7 elements are classified as metalloids. The 7 I counted: boron, silicon, germanium, arsenic, antimony, tellurium, and tellurium. And astatine. Astatine is not written here. One of the metalloid is silicon, which is a semiconductor. Germanium also a semiconductor used in chip industry. They conduct electricity under applied voltage, but becomes a conductor at higher applied voltage. So this silicon and germanium is used for integrated circuits to create chips. Therefore, it's very important. Now I'm going to look at some of the properties of this is group 1 or 1A. This is group 2. Transition metals is to 11. Lanthanide is at the bottom of the periodic table. Lanthanide, then that's group 17. That's group 18. These are main groups. They contain groups which have certain prominent features. First group is called alkali metal. They contain sodium, hydrogen, lithium, sodium, potassium, rubidium, cesium. Second one, group 2A contains calcium, magnesium, calcium, beryllium, radium. Transition metals are the yellow area. Do you have a question?
No, sir.
I am hearing voices here. Okay, so we're going to talk about more about these properties as we go along. Like I said, these are metals, these are non-metals, these are metalloids, non-metals, metalloids. Non-metals have certain characteristics. Metals have certain characteristics. Metals have these non-metals and metalloid. So we briefly talk about it. Metalloids are semiconductors and non-metals don't conduct electricity. They're brittle. Metals have certain properties, ductility, malleability, conduct electricity. We talk about that. Let's answer a few questions. Sometime I can hear you. In modern periodic table, arranges the elements in the order of. Now in the Mendeleev table, you started with atomic weights, but modern periodic table is based on atomic number of protons. They happen to be following the same trends when you use atomic number or atomic weight. But the atomic number is the best fit for creating a periodic table. Year of discovery, no. We are not arranging size of the nucleus, no. Increase in reactivity, no. Increase in number of protons. That's the correct answer. Which of the following elements is a gas at room temperature? We talked about that. Bromine is a liquid. Helium is belong to noble gas. That's a gas. That probably is the correct answer. Carbon is a solid. Sodium is a solid. Therefore, correct answer is the B. Which of the following element is not a solid at room temperature? Iron is a solid. Silver is a atomic symbol for silver is Ag. Xenon and aluminum. Aluminum is a solid. Therefore, these are not answered. Xenon is a noble gas. Therefore, that's the correct answer. Correct answer is C. Elemental symbol of mercury. That's gold. That's a Latin name for gold. Symbol is Latin name for mercury. Latin name for silver. Latin name for lead. The mercury is this one. Therefore, answer is B. What is the symbol of copper? So we have the choices. This is chromium. It's not. This is cobalt. That's not. This is carbon. That's not. Copper is a Latin name. There's no U in there. Cuprium. Cuprium is a Latin name. So Cu is the correct answer. Answer is D. Now, these are the questions we asked for from the periodic table. Names of the symbols, names of elements, elemental symbols. What element is ruthenium? This is Rutherfordium, Rf. This is Rh, rhodium. This is ruthenium, Ru. Rubidium, this is Rd. So this is the correct answer. Which element symbol is sulfur? That's silicon. Sulfur is S. That's the correct answer. Scandium is Sc. Selenium is Sc and Se. So B is the correct answer. Antimony is a metalloid. Metalloid is element in between metals and non-metals. It has 51 protons. It's alloyed with lead and used in the car batteries. What is the element symbol for antimony? A is not a chemical symbol.
If they say go,
You have a question? Okay. Ai is argon. Astatine. Antimony is a Latin name, stilbium. That's the correct. This is chromium. So this is the correct answer. D. Group of families. Group is a vertical column. Families are horizontal rows in the periodic table. The element in a column, that's the vertical groups, are known as a group. It's not a metal. Period is horizontal rows. A series is transition metals. It's not in a column. Metalloids is not on a column. So that A, the C, A column is a group. What are the horizontal rows of a periodic table? That's the period. Cycle is not correct. Families are group of elements in a group. So therefore answer is B. We're going to look at examples of certain periods in the certain columns in the periodic table. This is alkali metals. Lithium, sodium, potassium, rubidium, cesium. Alkali metals have increasing melting point and boiling points from bottom to top. Alkali metals are in group 1 or 1A. So this is the atomic weight calculated based on isotopic masses. We don't have to do each one of them. It's already done for you. So in the alkali metal group, boiling melting point increase from bottom to top. If you look at group 7A, this is 7. This is the group 1A. Group 7A is fluorine, chlorine, bromine, iodine. Fluorine is a gas. Bromine is a liquid. Iodine is a solid. So if you look at their boiling point and melting point, metals increase. Remember, metals was increasing from bottom to top. Is opposite behavior for non-metals. This is the group 7A or group 17 column number. Chlorine, chlorine, bromine, iodine, and acetylene. This is the noble gases last group in the periodic table here. Helium, neon, argon, krypton, xenon, radon. So they follow the same pattern as non-metals. So they have the same properties. Atomic melting point and boiling point increase going from top to bottom. So there's some periodic behavior in the periodic table. Which of the following elements have similar chemical properties to tellurium? You have to find the periodic table where tellurium is, sulfur, selenium. If you look at the periodic table, this is the sulfur group, sulfur, selenium, tellurium. So oxygen, I went further. Okay, oxygen, sulfur, selenium, tellurium. Therefore, only element here is sulfur is given. It could have been oxygen or selenium. So tellurium has the same chemical properties, is in the same group. Which of the following element is classified as semi-metal? There are 7 of them. If you remember, boron is one of them. That's the correct answer. Which of the element characterized by properties of ductility, malleability, and ability to conduct heat and electricity? That's the metallic elements. Which of the following elements is a good conductor of heat and electricity? That's a metal. Carbon is not a metal, non-metal. Aluminum is a metal. Chlorine is a non-metal. Neon is a noble gas. Basically, noble gases behave like non-metals. So answer is B. Which element is most likely to be a good conductor of electricity? Argon is a gas, noble gas, non-metal. Nitrogen is a non-metal. Fluorine is a non-metal. Nickel is a metal, transition element. Oxygen is a gas. So therefore answer is D. Next Monday.
Okay. Thank you. Bye, sir.
Yeah,
Okay, thank you. Have a good day.
yeah, you too.